In this lesson, we will discuss quantity of electricity. When electricity is passed through an ionic compound in molten or solution form, it is decomposed to obtain products at the electrodes. Experiments have shown that the mass or volume of elements of the products formed depends on the following factors: amount of electricity passed, length of time taken to pass the steady current, and change on the ions of the element making electrolyte. The coulomb is the practical unit used to measure the quantity of electricity or charge. 1 coulomb of charge is transferred if a current of 1 ampere flows through a circuit for 1 second. That is, 1 coulomb equals to 1 ampere per second. Generally, if Q coulombs of electricity flow along a wire for T seconds, the electric current produced is given by I equals Q divided by T. Rearranging the equation, we obtain Q equals IT, where Q is the charge in coulombs, I is the current in amperes, and T is the time in seconds. Calculate the quantity of electricity passed when a current of 0.6 ampere flow for 50 minutes. During electrolysis of a molten binary compound, a current of 2 amperes was allowed to flow. If a total of 3,600 coulombs were passed, how many minutes were the compound electrolyzed? Michael Faraday investigated the quantities of substances deposited during electrolysis. He found out that the mass of the substance deposited or liberated at the electrode depends on the electricity passed. To find the mass of copper deposited from aqueous copper 2 sulfate by a known quantity of electricity, the current was recorded in amperes and the time in seconds. A sample of the results were recorded in the table. The information on the table can be represented in a graph as shown in the illustration below. The graph shows a straight line passing through the origin. This indicates that the mass of copper deposited is directly proportional to the quantity of electricity passed. The relationship between the mass of a substance produced and the quantity of electricity passed is the basis of Faraday's law of electrolysis. Faraday's first law of electrolysis states that the amount of substance consumed or produced at one of the electrodes during electrolysis is directly proportional to the amount of electricity that is passed through the electrolytic cell. A student set up an experiment for the electrolysis of copper 2 sulfate solution. A current of 0.5 amperes was passed through the circuit for 3,860 seconds. A mass of 0.64 grams of copper was deposited. Which electrode gained mass? How many coulombs are needed to deposit 1 mole of copper? RAM of copper equals to 64. A current of 2.0 amperes was passed through molten sodium chloride for a period of 161 minutes. 4.6 grams of sodium were deposited at the cathode. How many coulombs of charge would give 1 mole of sodium? Through many experiments, it has been established that 1 mole of electrons is equivalent to 9,650 degrees Celsius. This quantity of electricity is the Faraday's constant and is denoted as F. Consider the following equations. 1 mole of silver ion requires 1 mole of electrons or 1 F to deposit 1 mole of silver atoms. 1 mole of copper 2 ion requires 2 moles of electrons or 2 F to deposit 1 mole of copper atoms. 1 mole of aluminium 3 ion requires 3 moles of electrons or 3 F to deposit 1 mole of aluminium atoms. Therefore, 1 F equals 1 mole of electrons, which is equal to 96,500 coulombs. During electrolysis of copper 2 sulfate solution, a current of 0.5 amperes was passed for a period of 3,860 seconds. The amount of metal deposited was 0.64 grams. Calculate the charge carried by the metal ion. Write the ionic equation for the reaction. RAM of copper is 64. During electrolysis, an aqueous solution of a salt of metal M, a current of 2.0 amperes was passed for 32 minutes 10 seconds. The mass of metal M deposited was 2.24 grams. Calculate the quantity of charge needed to deposit 1 mole and calculate the charge carried on the ion. The process of electrolysis has many applications. Electrolysis is used in the extraction of metals. The process of electrolysis is also used in the refining of metals. Electrolysis is also used in electroplating metals.